required an in-depth understanding of materials but also precise calculation of the tension in the ropes to achieve the desired launch velocity. Engineers of the time had to experiment with various materials for these ropes, searching for the perfect combination of strength and elasticity, often using animal sinews or hair. One of the most iconic catapults of history, the trebuchet, took the concept of potential energy conversion to a new level. This colossal machine, with its massive counterweight, could hurl projectiles weighing hundreds of kilograms over great distances. Its engineering was a true feat of mechanical genius. Engineers had to calculate the weight of the counterweight, the length of the throwing arm, and the precise timing of the release to ensure the payload reached its target. Balancing these factors required a deep understanding of physics and mathematics, combined with a keen eye for precision in construction. The trebuchet showcased the potential of engineering to solve complex problems and achieve remarkable results through careful design and rigorous testing. The spirit of human achievement that catapults embody can be seen in their continual evolution and adaptation. As societies progressed and encountered new challenges, engineers refined and reinvented these machines. In the hands of Roman engineers, the catapult evolved into the formidable ballista, which added a level of precision to projectile launching that was unparalleled at the time. The ballista's intricate torsion springs and clever trigger mechanisms demonstrated how engineering innovation could adapt to changing needs and advance the capabilities of ancient warfare. In essence, catapults represent a testimony to the indomitable human spirit, driven by a desire to overcome obstacles and seek new horizons. The engineers who crafted these devices, often with limited resources and tools by today's standards, displayed a remarkable blend of creativity and practicality. They weren't merely solving problems, they were pushing the boundaries of what was conceivable in their time. Let us delve into the world of catapults and explore what makes them so fascinating. Catapults are devices that use stored energy to launch objects over a distance. Their history dates back thousands of years to civilizations such as the Greeks, Romans, and Chinese. These early designs were ingeniously crafted, featuring the leverage of mechanical advantage to achieve impressive projectile velocities. The core principle that catapults rely upon is the conversion of stored energy into kinetic energy to launch objects over a distance. This concept is at the heart of their engineering. Stored energy is the potential energy that is carefully harnessed and then suddenly released, propelling the projectile forward. The genius of catapults lies in their ability to transform this stored energy into mechanical motion with remarkable precision. When we look back at the historical development of catapults, it's so inspiring to see how civilizations such as the Greeks, Romans, and Chinese were able to construct such sophisticated machines. These early designs were nothing short of engineering marvels. The key to their success was the leverage of mechanical advantage, a fundamental principle of physics that they had mastered. The catapult's mechanical advantage can be attributed to the use of levers, counterweights, and tension mechanisms. By employing these elements, ancient engineers were able to magnify the force applied to the projectile. Take the trebuchet, for instance. This type of catapult featured a long arm with a counterweight at one end and a sling for the projectile at the other. When the counterweight was released, it created a torque that rapidly accelerated the projectile. This design allowed for impressive projectile velocities and extended ranges. The intricacies of catapult engineering do not stop at leverage. In the case of tension catapults, such as the ballista, twisted ropes or springs played a pivotal role. These materials stored energy when they were tense and, upon release, transferred this stored energy to the projectile. The meticulous design of these components was critical for their proper function. Engineers had to calculate the tension, material strength, and release mechanisms to ensure accuracy and effectiveness. Moreover, catapults were often constructed using a combination of materials like wood, metal, and leather. Each component had to be crafted with precision to withstand the immense forces generated during the launch. The choice of materials was a crucial aspect of catapult